Hello everyone, ito si Dr. Esperanza at kung bago kayo sa channel ko, ako ay nagbibigay ng mga math videos mula sa algebra hanggang sa college level calculus. And for today, andito kayo ngayon sa workshop ko at for the next 20 minutes or so, tuturuan ko kayo kung paano mag-solve ng quadratics kasama ng mga estudyante ko. So stick around at matuto na kayo kay Dr. So we're going to be working on the second part of our finding solution of a quadratic equation, factoring. Factoring is another method that we use for algebra so that we can find the solution without graphing it or without seeing the graph. That's why I've been reiterating this over and over again. You need to focus and you need to make sure that your factoring technique is spotless so that you'll be able to answer a lot of functions in the process, because that's how it is, that's how math works. Okay, let's start it. Let's have the zero product property. This is a certain property in mathematics where it says that if the functions is in factored form and you're finding its solution, all you need to do is to set both factors to 0 and solve for x. And that's how you will find your solution. So we'll keep it simple. We have a function and the function is x times x plus 3. And according to the zero product property, if we equate y equal to 0, which means we're going to equate y equal to 0, we'll be able to solve this using ZPP. And what does ZPP mean? Just like what I've mentioned a while ago. Hopefully you're understanding what I've been talking about, but it's basically equating both factors into 0. The first factor is x, the second factor is x plus 3. And we're going to equate it to 0. And that's how we do it algebraically. Factoring it, equating it to 0, and then solving for x. Do we need to solve for x for the first set of solution? No. We know that it's x equal to 0. Do we need to solve it for the second one?
Yes.
Of course. How?
Minus 3.
Yes. So it's x minus 3. Now, these are the solution, and we know that this is how the graph of the parabola is going to intersect on the x-axis, right? So we can sketch it, because we know the definition of a parabola and we know what the solutions are. So let's sketch it. How does this parabola open? Upward or downward?
Downward.
Up or down?
Down.
Like this?
Negative.
Yeah.
Why?
Because the negative 3.
Because you gotta go to 3.
Because it's negative, you gotta go to 3. Okay. Let's modify the quadratic equation so you can see it better. How are we going to modify it? Multiply it. X times x, x times 3. This is the standard form. Okay. Another vocabulary. This is the standard form of the quadratic formula, and this is the factored form. When you're looking at the factored form, guessing if the parabola is opening upward or downward can be a little bit challenging. But if you change it into the standard form, can you now confidently say how it's opening?
Upward.
Upward. Why is it upward?
Negative.
Yeah, because quadratic term is positive. So if it's upward, according to this, it's passing to 0 and 3. This is 0, x is equal to 0, and x equal to negative 3. 1, 2, 3 is here, right? And it's opening upward, so smiley face, right? Rough sketch of the graph. This is not an accurate representation of the parabola, but at least we know how it looks like, because these are your solution, but we don't know if the vertex is right. We'll go there next time, but at least we know that it's how it looks like. All right. So factor, ZPP, now you have two solutions. So if I have this, can you give me the solution now of this quadratic equation? So what you're doing is you're finding the solution algebraically, not graphically. And using the zero product property, you'll be able to solve this with a little bit of algebra. We need to use this. And zero product property is equating your function to 0, which means you will equate 3 minus x minus 5 and x plus 3 equal to 0. And by doing so, you can split it into 3x minus 5 equals 0 and x plus 3 is equal to 0. This is the zero product property. And then we'll solve for x. And now we'll find the solution. What's the first move to solve for x on the first one?
Plus 5.
What's the next move?
Divide 3.
Divide 3. So what is x?
5/3.
That's the first solution. And what is the second solution?
-3.
Minus 3.
From both sides.
So we have two solutions by Kiani. And those are 5/3 and -3. Alright? And this is your zero product property because you factored. So before you can use the zero product property, make sure that you are using the factored form of the quadratic equation. So it's extremely important you know how to factor because before you can use ZPP, your y or f of x needs to be in factored form. So this one is still easy because it's still basic algebra because you're basically solving simple linear equation. 3x minus 5 equals to 0 and x plus 3 equal to 0. You have 5/3 and you have -3. What about if you have... Is this quadratic equation in factored form? No. So if it's not in factored form, because obviously it's in standard form, can we use the zero product property? Not yet. We cannot use it yet. We need to modify the function to make it look like a factored form, so the zero product property will work. We have to find the solution of the quadratic equation by factoring. So, if I have x squared plus 7x plus 12, do you still remember how to factor functions like this? Of course. You need to see 12, and you need to see 7, and you need to find the two numbers that when you multiply will equal to 7, but when you add them up should equal to, when you multiply should equal to 12, but when you add them up will equal to 7. What are those two factors of 12 that we're looking for? 3 and 4. Positive, negative, negative, positive. Positive both. And by factoring it using this method, the two factored form, so if I have y equals x squared plus 7x plus 12, the factored form of your function is going to be x plus 3 and x plus 4. And now, by equating it to 0, we can now solve it using ZPP. So that is why sometimes the function is already in factored form, so it's easy, and sometimes you need to do a little bit of mathematics. And that's the second method, factoring method. Now, we know that there are the factors. We know how to solve its solution by solving it for x. So if I have this, let's find the solution of this function. Obviously, there's no graph, so to be able to find the solution, we need to do math. Is this a factorable quadratic equation? Yes. So if I have -15, and I need to find the two factors, what are the two factors? Positive and negative, right?
3 and 5.
And it will be 3 and 5, but which one is negative?
3.
And now we have solved the puzzle. 5 times -3 is -15. -5 minus 3 is equal to 2. Now we can factor this. So the new equation will turn into x plus 5 and x minus 3. They're the same, right? They're just different style. Now we can use the zero product property. X plus 5 equals 0 and x minus 3 equal to 0. So if we're going to solve it, subtract 5 on both sides. X is equal to -5, add 3, and x is equal to 3, right? Now if we're going to sketch the graph, The solutions are negative 5 and 3. So negative 5, 1, 2, 3, 4, 5. That's negative 5. Positive 3, 1, 2, 3. That's positive 3. How is it opening?
Upward.
Upward. So that is the rough draft of your parabola. And we're able to solve it using ZPP or factoring. Because the factor is x minus 3 and x plus 5. Using the zero product property, we're able to solve it. And now we know we can graph it because at negative 5 and at positive 3, the parabola that is opening upward is going to look something like this. So what we're doing is we're doing it backwards. We're not seeing this, but now we're generating the graph by just looking at the equation. Factoring. How about this? If we're going to solve for this one, last term is negative 8. We have positive 6. Can you think of a factor or factors of negative 8 that when you add them up will equal to 6? 4 and 2?
Negative.
Negative? Okay, negative 4 times 2 is negative 8. Negative 4 plus 2, is it 6?
About negative
No.
1 and 7.
What about negative 1 and 7?
Yeah.
Negative 1 and 7. Negative 1 and 7 is not negative 8 when you multiply it. But negative 1 plus 7 is 6, yes.
Closer.
But no, they're not the factors we're looking for.
About 1 and 8.
1 and 8. This is 8. We're looking for 6, and we will have 1 and 8. 1 times 8 is 8, but is it positive 6? Okay, I'll save you the trouble. It's not factorable.
It's not factorable.
However, we can modify it. Here's the clue. This is something that you should see in a math problem. Every time you have a negative quadratic term, you can take out the negative so it will turn into a positive. So this one can be changed into negative outside, and what's left inside?
X squared plus 6.
Mm-mm.
6, 12.
Because you undo or factored out the negative 1. So if you factored out the negative 1, essentially you're pulling out the negative, so all the signs will be changed, right? Now, let's see if it's factorable. 8, negative 6. Is it now factorable?
Yeah.
What are the factors that you can give me? Yeah, it's correct. Negative 4 times negative 2 is positive 8. And negative 4 plus negative 2 is negative 6. So now we have the factors. And what are the factors? X minus 4 and x minus 2. And if we solve it, x is equal to
4.
and x is equal to
2.
2. So we have the two solutions. So if we're going to graph it, positive 4, positive 2, right? How is this opening?
Downward.
Downward, because in the original function it's negative, so it will stay negative. We didn't change it, we just solved it. So this is going to look maybe something like this. Got it? So watch out for the negative quadratic term. If it's a negative quadratic term, try to take out the negative so it will become positive, because it will become factorable once you take it out. So you have two factors, ZPP, and you have your solutions at 4 and 2. The parabola is opening downwards, and that's how you solve it. Because mathematics, it makes sense. If you know the language, if you're understanding the words we're using, and you're understanding the rationale behind it, as opposed to memorizing the rules, memorizing that this is step 1, step 2, step 3, you're not going to learn it or appreciate it. Because you are going to appreciate mathematics better if you're understanding it. You may not be able to master it right away, but at least your foundation is good because now you're understanding what you're supposed to be doing. Is this factorable? Yes. There are the factors. We find the solution, and we have negative 3 and negative 4. Now, this one. Can you find the solution of this quadratic equation?
Yes.
Okay, so let's solve it. So in this case, we're not going to be using the same technique. We're going to use a different technique, factoring by grouping. So we will multiply 2 and 7. And what is 2 times 7?
14.
And this is the magic number we're going to look for because there's no factors of 7 that will give you 15 when you add them up. No, the highest is 1 and 7, and it's 8, right? So it's never going to be 15. But if we multiply this 2, which is 14, what factors of 14 that when you add them up will equal to 15?
14 and 1.
14 and 1. Because 14 times 1 is 14, 14 plus 1 is 15. So now this one is a different factoring technique. So just follow me, and if you don't know how to factor this out, I have the video of this particular factoring technique. So push that button and learn how to factor out a quadratic equation when the leading term is more than 1. Going back. Alright, so this is how we're going to solve this. So we'll have 2x squared. We copy this. And the new middle term is going to be 14 and 1. So plus 14x plus 1x plus 7. So essentially, we just modify the function so that we can apply the factoring by grouping. And by grouping it, we'll find its GCF. And the GCF of the first one, what?
2x.
2x. So if 2x is outside, what is left inside?
X and 7. X plus 7.
X plus 7. And what about the GCF of the second group?
1.
Positive or negative?
Positive.
Positive 1. And what is left inside?
X plus 7.
And what do you notice about the two terms?
There's 2 the same.
There's 2 the same, or GCF. So now we'll do the GCF all over again. So x plus 7 is out. And 2x plus 1 is in. And now we can solve for x because it's now in factored form. And finding for x will be easy because for this one, x plus 7 is equal to 0. What is x?
Negative 7.
And this one, 2x plus 1 equals 0. You subtract 1 on both sides, right?
It'll be half.
It will be
1 half.
positive or negative.
Negative.
So, what I'm trying to show you is not all quadratic equation can be factored out easily. Sometimes it could be challenging. That's why before you master solving quadratics, you need to have mastered the factoring techniques because there are several quadratics that you need to factor, and sometimes you need a different technique to factor it out. And again, watch the video if you want to see how it's done. I have more examples of this. So we have negative 1/2 and negative 7. Alright, how about this? Can you factor this?
Yeah.
Yes, let's factor it. It's a different quadratic equation, but you know you can still factor it out using what method? What method are we going to use here? GCF, right? Finding the GCF. And what is the GCF of this function?
X or 6x.
6x. So 6x is our greatest common factor. So 6x is outside. 24x squared divided by 6x.
4x
And this divided by 6x.
is just 1.
So it's just minus 1. And now we have the factored form. So we can use the ZPP. 6x is equal to 0. 4x minus 1 is equal to 0. Divide both sides by 6. And what is the first solution? 0 over 6 or 0. And what is the second solution? Add 1 on both sides. And divide by 4. 2 solutions. So notice that we always have 2 solutions because it's a quadratic and the highest exponent of 2. So the exponent or the highest exponent of your function dictates the maximum number of solutions you will have in a function. So since all the functions we're using are quadratics, most likely we'll have two of them. Just like what we have here. Factor, answer. And then the graph, we don't need it. Alright. How about here? So when you see this type of problem, you don't need to factor, but you can use it or you can solve it by regularly solving for x just like a linear function. Solve for x using the square root property. What will be your first move?
Minus 32.
Minus 32?
Or plus 32.
Next move?
Square, or divide 18.
Can 18 go to 32 perfectly? How many times 18 goes to 32? Twice. Yeah, 2 times 18 is 32, right? Are we finished?
No.
What's the next move?
Square root of both sides.
Square root. But we're not doing square root of 18. We're doing 32 divided by 18.
Oh.
So we have x squared equal to square root of 2. Am I missing any symbols that I need to include in my answer?
Plus or minus.
Plus or minus. And do you have a square root of 2? No, it's probably 1 point something, right? So this one is a parabola opening upwards, and the solution is plus or minus square root of 2. So if this is your xy plane, this is 1, this is 1, this is 2, this is 2. Square root of 2, approximately 1 point something, right? So somewhere here, somewhere here. The negative and the positive side. And it's opening upward or downward?
Upward.
So that is the graph of the parabola. Can you solve this on your own? Try it. How many x's did you find? 1 or 2? Got 1? Let's see. Y equals 3x squared plus 7. I will equate y to 0, which means I have 3x squared plus 7 equal to 0. And then I'll solve it like a regular linear equation. Minus 7, 3x squared is equal to negative 7. Divide by 3. Divide by 3, right? So I have x squared is equal to negative 7 over 3. Can I, what's the next move? Square root it. And positive or negative, right? Now, what is the square root of negative 7 over 3?
Does not equate.
No solution does not exist. Why? Any number or any number that is a square root of a negative number does not exist. If you use your calculator and push square root of negative 7 at least, it will give you an error message. So this one has no solution. And if it has no solution, why do you think this quadratic equation has no solution? Again, the solution is the point of intersection of the graph on the x-axis. So what do you think is happening in your graph when you did the algebra and it has no solution? How do you visualize it? What is special about the graph of this function and why it has no solution?
It won't intercept on the x-axis.
It won't intersect the x-axis, and that is correct. So whenever you're seeing this mathematically, even if you're not seeing the graph, you should know that the reason why there's no solution, or the reason why it's the square root of a negative number, it's because that parabola is not intersecting the x-axis. Let's sketch the graph for visual. Is this parabola opening upward or downward?
Upward.
Upward. And is this parabola intersecting the x-axis? No. So if you graph this using a graphing calculator, probably it's something like that. Maybe, I don't know. We need to graph it to make sure that's the accurate graph of that parabola. But we know that it's opening upward and it's not crossing the x-axis. That's why on the first slide, we counted the number of solution of a parabola. Sometimes it's no solution, sometimes there's just one solution, sometimes there's 3 solutions because of this case. What if I have this example? Is the quadratic term positive? So you don't need to take out the negative sign, right? Can you think of the factor of 4 that gives you negative 12 when you add them up? Can you think of factors of 4 that gives you negative 12 when you add them up? Do you think it is possible? I know we can still get negative 12 for that, but is it going to be a product of 4? Because this quadratic equation is not factorable. So what will happen if it's not factorable? What will happen if you're not seeing the graph and it's not factorable? How are you going to enter it? You'll go home and cry. That's why we have the third method. If it's not factorable, we can use completing the square method. I know it sounds... And again, ito si Dr. Esperanza. At kung nagustuhan niyo yung video ko, please like, share, and hit that notification button. At i-share niyo na ito sa mga friends, teachers, at mga kaklase niyo para mas dumami pa ang mga students and teachers na matulungan ko. Bye!